All right, well, thank you very much. And hello to everyone watching. Like was said, my name's Mike Geig. I'm a technical evangelist at Unity Technologies. And today I want to talk just a little bit about what Unity is, how we can use it, and how we can scale easily using, Unity services and, stuff like Visual Studio to make our lives quite a bit easier. Because these tools have progressed quite wonderfully over time, and they make this whole process quite simple. So I'm not much of a PowerPoint guy, but I gotta, our folks would kill me if I didn't at least introduce Unity for anyone here who wasn't familiar with it. So Unity is based on these three core principles, right? The idea that we want to democratize development, meaning we want to make it easy for everyone to make games. And I think that's very important, very core to what we do, is we want everyone to be able to make games. We also want to solve hard problems. We want to implement the things that you don't really care about implementing yourself. You don't want to create your own physics, your own rendering, your own this, your own that. And so we implement those for you so you can focus just on your game. And finally, we want to enable success. We want to give you the tools you need so that you're successful long after your game has been released. And one of the things that makes this so capable is the ability to deploy to many, many platforms. I believe we're somewhere at like 27 platforms, something ridiculous, but we deploy to pretty much every conceivable platform, and that makes it so you can more or less build your code base once and deploy to any platform you might want to be able to deploy to. And now we got some slides. These are just many of the games made with Unity, which are pretty cool. I'm just gonna go through these quickly because, like I said, I am not a PowerPoint kind of guy, but we've got Rust is super fun, Cities Skylines, super good. Recore is pretty awesome. Super Hot, if you haven't played it, I highly recommend it. It's awesome. Eagle Flight, which is always super duper fun. One of the ones not on this slide is the new Rick and Morty game. Augmented reality games like Pokemon Go and all these other mixed reality applications for business and industry. And then Unity is being used more and more for film and entertainment, which is really, really cool. So I don't know if anyone's seen Asteroids or 0 Days, but really awesome sort of renderings and stuff done with Unity. All right, no, and beyond entertainment, I had one more. So there we go. Like I said, not much of a PowerPoint guy, but mostly just wanted to sort of go through, okay, Unity is this cross-platform tool. We deploy to just everything. We're focusing very heavily on graphics and performance nowadays. We're really trying to make it so people can make games with Unity very easily, very quickly, and just, make awesome stuff. Okay, so let's get into the actual demo here. So here I have the Unity engine open, and we've got a bunch of windows. I'm not really going to focus on all what they do right now. I'll talk about them when they become important. So I have this sort of blank scene, which means I'm just looking at this blue sky and brown ground and whatever, and I could add some primitive stuff to this scene. I could go over to this window called our hierarchy window, which lists everything that's in our scene, which right now we can see we have a camera and a directional light. And I could, just start adding some like primitives like a cube or whatever, but that's super duper boring. I don't want to do cubes. So instead, I'm going to come down to this window that's called my project window. These are where all of the assets or files that are part of my project live. So assets are, materials, textures, models, scripts, audio files, whatever. And I'm going to go to my models folder, and I'm going to go to my environment folder. And I'm going to see that I have a lot of these models. And I didn't make these. I actually found these on the asset store. So if you're ever wondering, hey, I want to get into game development, but I don't have all this stuff, what can I do? You can just go up to your window and select Asset Store. And you can find all sorts of stuff to download and start building games with, all sorts of models and asset packs and all sorts of stuff, right? There's a lot of really cool stuff on here. So I downloaded this 3D floating island asset pack, and I could just now start building a game. I could see in my scene view here, there's nothing really here yet. So if I want to add, a piece of ground here, I can just click it and drag it in, place it where I'd like. And I can move around here and maybe grab another piece of ground and put that here and just start building something. That's one of the things that Unity does very well. It has these very refined workflows that allow you to build and prototype and sort of design very easily. So you can see I've got 2 pieces of ground here, and I can manipulate them in my scene using my scene tools like you would expect. And I could, again, very quickly just start saying, all right, well, now let me put a bridge there and maybe just lower the bridge down a bit. There we go. So now I have a bridge. And let's put a big old tree here where someone might live. All right, and now just start prototyping, clicking and dragging. It's what I like to call drag and drop ability, which I'm going to patent that term eventually. Drag and drop ability, where we're just gonna drag stuff and be like, yeah, that looks pretty good there. Maybe just, well, no, that one's not good, but whatever. And some bushes, whatever. And so I can just quickly click and drag and bring around and start prototyping something pretty easily. Now, I'm not going to end up using this scene here because, you know, I just put this together pretty quickly. So instead, I'm going to go down to my scenes folder here in the project view, and I'm going to open a scene that I've already started putting together using pretty much the exact same techniques, right? So all I've done is just clicked and dragged a bunch of stuff, and this is what I've built. And so I've got some little goal area here where I want to go, and I've got some stairs and a big main area here and a south island, and then this sort of west island over here. So this is where my gameplay is going to take place. And again, all I've done is just dragged and dropped. Nothing really, you know, special or different or anything like that. Just moving around and changing stuff around. And so now what I want to do is I want to add a character that's going to be my player. So I'm going to go back to my models folder, and I have this other one, again, from the asset store called Mini Viking. I believe it's Mini Viking Eric on the asset store. And by the way, if you want to see the assets that I am using today, you can. If you go to the asset store, either in the in your browser, just search Unity Asset Store, or within the engine here, you can look up me, Mike Geig, or you can just look up the list Viking Quest, which is the name of this project that I show. And if you click on the list Viking Quest assets, you can see all of the assets from the asset store that I used when making this. So here's the Viking, here's the floating islands, some skyboxes, some particles, things like that I used when making this. All right, so I'm going to go into this Mini Viking folder here, and I could choose whether I want to use the Viking who has axes, right? We can see him right there. There he is, or the Viking with a sword. I think the last time I did this, I went with axes, so this time I'm going to go with swords. And so I'm just going to click and drag him in. You'll see he'll track to the surface here, and I'll just place him on this little altar thing right there. And that's where I want my player to start off. Now, in and of itself, my player isn't really doing anything, right? I need to add some behavior, and there's a few ways I can add behavior. So first off, I can add a series of built-in behaviors, which we call components, or I could write some code and create my own behaviors. And so I'm going to do a little bit of both. Some combination of the two is where I'm going to end up. And so the first thing I want to do is I want to tell Unity that this character, this Viking, is a physical entity. It should be able to fall, it should be able to push, it should be able to pull, it should, you know, react with physics, it should be dynamic. And so I need to add to it something that I just mentioned called a component, right? Some modular functionality. Now, before I do that, I want to dig a little bit deeper into the concept of a component. So before, in our hierarchy view, where we're seeing the things that are in our scene, the list of these game objects, you saw that we had a camera and we had this light. Now, if you wonder what makes this light a light, it's really just a light component, which we can see over here in the inspector window. The inspector window can be thought of like a properties window. This is where we're just seeing whatever, all the information about what we currently have selected. And so this directional light has a light component. Now, if I remove the light component, it stopped being a light. And if I added a light component to anything else, it would become a light. My camera, again, just has a camera component. So if I wanted to, I could say, click on this tree here, and I can see what this tree does. So the tree has a mesh filter, so it contains a mesh renderer, which is how I can see it. Right, I can see it because it renders a mesh, and a mesh collider, meaning that if I ran into it, it would be physical. It has some physical boundaries. But let's say I wanted to add component camera. Well, now my tree has a camera, and we could see what the tree sees. And if I wanted to add component light, I could add a light, and now my tree can shine. Let me just increase its intensity. Boom. Now I have a shining first-person tree game, which we can see right down there in that little preview. So these modular behaviors, these components, can be added to anything, and they're very basic, and you can stack them up in these game objects to create cool custom interactions, unique ways for them to behave and perform. So that's basically what components are. So now I'm going to come back to my Viking here, and let me just sort of minimize that there. And I can see that my Viking has this transform. All game objects have a transform, which is their position, rotation, and scale in 3D space. It also has an animator, which we're not using yet, and we'll talk about here in a little bit. And I can see that my Viking has this arrow next to it. I can expand it, and I can find that it has an alpha object, which has a skin mesh renderer, which is drawing his hair and beard. And then he's got the skin mesh renderer for the rest of him right there. That's just all part of the model. When we drag a model in, an FBX file, Unity is going to associate it with all that stuff. And so on this Viking, the Viking sword, I want it to behave physically. And so I'm going to go to Add Component, and then Physics. And you'll note we have two types of physics. We could do 2D physics, which is Box 2D, or 3D physics, which is NVIDIA's PhysX. And you can have both of them in the same project. You can have both of them in the same scene. They just don't interact with each other, but you could have 2D and 3D physics on objects and stuff like that, all in the same scene. It doesn't really matter. And so I'm going to go to physics, and I'm going to say this is a rigid body. A rigid body means it is going to push and pull and behave and function and form with physics. And so now what I'd like to do is I want to run this simulation. I want to see what this will do. I want to test this game, right? And I don't have to do a build. I don't have to do anything special to do that. I just can come to the top here and I can enter what's called play mode. And so it will actually run as if it would on device with all of my inputs and everything else. So I'm going to hit play, and my Viking is just going to fall straight to the ground because we gave him physicality. We gave him a rigid body. We said he's going to fall, right? But we didn't in any way give him physical constraints. He's just a mesh that falls. He's not solid. And so we need to give him some solidity. And so I'm going to go to Add Component, Physics, and I could do a bunch of different types of colliders, but I'm just going to go with something simple. We don't really need complex physical interactions in this game. So I'm going to add a capsule collider. Now, the way this character was modeled, its root, its origin is at its feet here, which is why the capsule collider is around its feet. And so what I'm going to do is I just want to lift it up so the capsule collider pretty much covers the model. Now, I could just type in some numbers in these fields for my capsule collider to raise its Y center value and to change its height. But anywhere that I have a numerical field here in the inspector, I can move my mouse just to the left of it and click and drag and just sort of range that value. So I'll do something like that. And I'll come down here and I'll just do something like that. There we go. And so now I can see I have this green collider around the Viking. There we go, providing physicality to it. And so now if I hit play, I will see that my Viking does not fall, stays right where it is. What's cool is while I'm in play mode, I can just come back to my scene view here and I can lift him up and drop him, right? I'm still in my simulation. I can move him around. I can, throw him off the side. See you, buddy. And then I'll just leave play mode and he'll be back. All right, so I can prototype safely and check that stuff out. Now, a moment ago, you heard me mention that we needed to raise the Y-axis center position of that collider up a little bit. And so how do I know that's the Y-axis? Well, if I look up here in my scene view, I can see this gizmo. This is our scene gizmo, our compass, whatever, and it has these labeled axes. Now, there's a lot of different software for modeling 3D stuff. There's a lot of different software for making games. Some of them are the same as far as axes go. Some of them are different. But Unity uses what's called a left-hand coordinate system. And what that means is if you take your left hand and you stick your thumb up, your pointer finger up, and your middle finger out, so it makes sort of like a gun pointing gesture, you'll be pointing towards the positive axes. So in Unity, positive X is to the right, negative X is to the left. positive Z is forward, negative Z is back, and positive Y is up and negative Y is down. So I knew I needed to lift that collider up, so I knew I needed to move it up along the Y axis, the green axis here. All right, so I have this Viking, it's got this rigid body, it's got this capsule collider, that's all well and good. And now it's time to actually give it some custom behavior. I want it to move around, I want it to jump, and I want it to be controllable by the player. There isn't really a built-in component for that, so that's where I'm getting into custom stuff. This is where I'm gonna write some code. And so I'm gonna come down here to my scripts folder, and I have a few other scripts in here. I'm just gonna ignore those for now. And I'm gonna save this script in the scripts folder, but I don't have to. The names of these folders don't really matter. I just do this for organization. And so I'm gonna right click down here in my project view, and I'm gonna select create, and I'm gonna create a C# script, which I will just call player move. And I apologize for the super loud keyboard. It's just the keyboard that I have. So this is gonna create this script and actually add some boilerplate stuff for me. And I'll just open this up. And it's gonna open up in Visual Studio. There we go. And so here we go. And I'm gonna just zoom in here, make that text super duper readable. All right. So this is the basic structure of a C# script in Unity. And I like to bring that down, it's personal preference. So at the top here, we have some using statements. We need to be using the Unity Engine API. That's gonna give us access to all the good Unity bits. We also add these other two, which this script isn't actually gonna need, so I'm just removing them. And then we can see this is a public class. The name of the class will be the same name as the file that I created. And I created a file named player move, so this is player move. And it is going to inherit from mono behavior. And that's what's going to give us, again, access to all of the Unity bits, is this mono behavior. Also note that it's using the European spelling of behavior. Now, I don't generally have to type this in because Unity just does it for me when I create a script. But because I've inherited from mono behavior, like I said, I have access to all the Unity API stuff, and I get the Unity callbacks. And so the two methods that exist in here automatically are the start method and the update method. And I will talk about what these do here in just a second. Before I work in here, I want to start defining some variables that my script is going to use. So first is I'm going to make a public float variable, which I'm going to call movement speed. And I'm going to set that equal to 5. And since this is a float, I could just do 5 and a semicolon like that, and that would be completely fine. If I did 5.0 though, that would give me an error. The reason it gives me an error is C# defaults to floating point numbers as being of type double. And Unity, which doesn't need so much precision because video games have to run faster with lower memory, defaults all floating point numbers to floats. And so just to make sure that Unity knows which kind I want, I'm going to put an F after it, and I generally just shorthand that to 5F, just like that. And so this is saying that I'm gonna have a movement speed variable, which has a value of 5F. Then I'm also going to create another variable here. So I'm going to create a public float jump force, which is going to define how much force I jump with, and I'm set that equal to 6F there, so 6 float. And finally, I need to be able to define what is the ground that, so I know when I've landed. All right, so what is my ground? What am I looking for? And so what I'm going to do is I'm going to create a variable called a layer mask. And we're going to see what this does. It's actually pretty cool. And I'm going to label it what is ground. All right. And I'm also going to make that public. Now you might be wondering, why am I making these variables public? All right. So C# defaults to private. We know that. And I am making these variables here public. And so what effectively happens when I do that is if I come back here and I'm going to click on my Viking and I want to add this new script as a component. So I can either just click and drag it here, or I can add it through the add component menu. So if I go to add component scripts, I should see my player move right there. And you'll notice right here, I have my movement speed, my jump force, and my what is ground layer mask. All right, because I made these public in my script, the Unity editor has access to them. So if I'm a programmer working with a designer, I can program this script, and then the designer can tweak these values without ever modifying my code, looking at my code at all, which is, you know, really good. Keeps them away from my stuff and keeps me away from their stuff, and everyone just sort of focuses on their own jobs, which is fantastic. Now, you might be concerned by the use of public variables, right? Code security is important. I get that. And so another thing you could do is, instead of public, you could instead keep it private, which, you know, I'll go ahead and write private out, even though I don't have to, because that's the default in C#. You can keep it private and just give it the tag or the attribute serialized field. All right, so now that means this variable, this member, can be serialized. And in doing so, I'll come back to Unity here, and it remains here in the inspector. So it is now private, but I can tweak it here in the editor, which gives me all that power without, you know, necessarily having code security issues, because I'm able to keep that stuff private. All right, so that is my my variables here that I'm going to use. I'm also going to find some other variables that are just going to be private that I'm just using inside the class here. And so I'm going to create a variable of type rigidbody, all right, which I'll call rigidbody here. And you might remember we added a rigidbody as a component to the Viking. So here I am having a variable of that same type, so we can modify it in code. I'm also going to create a vector3. A vector3 is a mathematics vector, not like your C++ vectors, which are more like lists, or, you know, containers, data containers. This is an actual struct called a vector3, which is going to store an X, Y, and Z value. We can use that to store positions. We can use that to store actual mathematical vectors, or we could use it to store whatever we want. It's basically just one variable that has 3 floats inside it, X, Y, and Z. So I'm going to create one which I'm going to call player input, and that's where I'm going to store the inputs from the player. That's a pretty good name. And I'm going to create a bool called grounded, which is going to determine whether or not we're currently on the ground. And I'm going to default that to the value of true. So we're going to say we're starting on the ground. Now, start is a built-in method for Unity. It's called by the engine if it exists in your code here. It's where we do our initialization. And so I'm going to initialize one of my variables here. I'm going to initialize my rigidbody variable. All right, so it's just a variable, but it doesn't actually point at anything yet. So I need to get a reference to that component. So I'm going to type get component, and which is a generic method. So I'm going to mention what type there. And so I'm going to get a component of type rigidbody here. And that's a capital B. There we go. And so that's the only variable I need to sort of initialize there. And now inside update, I'm going to go ahead and start doing some code for my jumping. Now, updates are basically your game loop, right? So update is going to be called once a frame by the engine. So this is where we do all of our normal iterative logical processing, right? And this is going to be called as fast as it can. Every update frame, you know, that might be 10 times a second, 60 times a second, 1,000 times a second, 10,000 times a second. You know, there's really no limit to updates, just as fast as it can, every update frame. And so here's the code we're going to put in here for iteration. Now, update is where I want to check for inputs. I want to figure out, you know, any one-off inputs, things that like when we push a button down for the first time and stuff like that. And so that's what I'm going to do. I'm going to look to see if we're trying to tell the Viking if the Viking should jump up in the air. And so I'm going to say if, and then I'm going to use a static class called input to test to see what sort of inputs we're getting from the user. So I'm going to type get button down, right? So I'm interested only when they press the button down for the first time. And now I'm going to pass in a string jump. And so obviously you don't have a jump key on your keyboard. Jump is what we call a virtual input axis. All right. And so we can have as many of these as we want. There are 18 built in by default. Jump is one of them. Jump defaults to the spacebar. The reason we don't do something like keycode.space, specifically looking for the spacebar, is that we want the ability to easily remap our controls. And if we do keycode.space, we'll have to, you know, parse and refactor our code every time we want to change what a key means. It also, by using these input axes, we have the ability to allow the player to remap their controls, right? If I were to do something like keycode.a, I'd be looking for the A key. but a player in a different country may not speak English, may not have an A key, right? And so, you know, they may need to remap that controller. I might need to create different bindings for that language. So we use these input axes. So jump is one of them. It defaults to the space bar. So I want to know, hey, did I just press the jump button and am I on the ground? Obviously, you can't jump if you're not on the ground. All right, so if I did press the space bar and I am currently on the ground, I'm going to say rigid body. Okay, so I'm going to do some stuff with a rigid body here. I'm going to do add force. So I'm going to add a force to this rigid body. And then inside here, we can see we have some overloads. And this is super nice. These tooltips make it so you really don't ever have to actually know any of this stuff because it just sort of tells you. So I can add a vector 3 force. I can add a vector 3 force mode. I can pass in an X, Y, and Z. And I can pass in an X, Y, and Z in force mode. And so what I'm going to do is I'm going to use this version. So I'm going to pass in a 0F. I don't want to move left or right on the X axis. I want to add force on my Y axis, and then I don't want to add any force on my Z axis, right? So I'm just moving up, jump force. All right, and then I'm actually going to use a force mode. And the default force mode is just force, which is your traditional force calculations, right? And we see here, add a continuous force to the rigid body using its mass. Well, I'm not interested in that because, you know, it'll move over time because force is basically applied over time. Instead, I'm going to use impulse, all right, which is going to apply an instant force, which is going to make my character pop up in the air. All right, so I'm going to do force mode impulse. All right, and then I'm going to say grounded equals false because we are no longer going to be on the ground after this happens. Now, this isn't the end of this script, but I do want to just come back here and see what happens. And so I'm going to come here and I am going to hit play and I should be able to jump. And there we go. Now I won't be able to jump anymore because we never set grounded back to true. We never detect when we're back on the ground, but I did jump that one time. So that's off in the right start. Now, I could do the rest of my code inside update. And update is going to run as fast as it can, but the rest of my stuff is going to involve interaction with other physical entities. This one was just looking for this jump button, and then we're adding a force. But the other stuff, I'm actually need to check for colliders and check positions of rigid bodies and stuff. So I'm going to use a different method that's also built into Unity called fixed update. Now, well, there we go. Visual Studio is going to add all this stuff in there for me, so that makes it nice and easy. And so with fixed update, it's going to be very similar to update. It's going to run over and over and over, an iterative process. However, it's going to run at a fixed time frame, right? So it's not going to run as fast as it possibly can. By default, this is going to run 50 times a second. That's set in the editor. Like I said, that's a default value from the physics engine. And this is fixed update will be called while Unity is doing all of the updates to all of its physical stuff, all of its colliders, its rigid bodies, whatever. That way, if I check for collision in this update, I know I'll be correct. If I check for collision in this update, in regular update, I might miss something because this is running asynchronously of fixed update, right? So I do all that physical code here inside fixed update. And so what I'm going to do is, first off, I'm going to say if, and then I'm going to call the physics class. So I want to look at the ground and say, hey, or I'm going to look at the character's feet and say, is the ground here? Am I standing on the ground? So I'm going to use a method called physics.checkSphere, which is going to create sort of an imaginary sphere where I tell it to and say, hey, is the ground here? All right, so I'm going to do physics.checkSphere, and it needs to know, okay, what position? Well, my character has a transform, so I'll do transform.position. So that's where it is, and we already noted that its root, its origin is at its feet, so that's perfect. And then it's going to say, okay, well, what is the radius? Well, I'm just going to do something simple. I'm going to just do 0.1 units, which is generally 0.1 meters when we're talking about physics. That's kind of a magic number. I really should put a variable and allow you to adjust that in the inspector, but you know, whatever. So 0.1f there. And then finally, I'm going to add a layer mask. And remember, we created this. What is ground layer mask? So I'm just going to pass that in. So we're looking for the ground. Now, if we find the ground, then grounded is true. We are on the ground. Else, we're going to say grounded is false. So we're either on the ground or not on the ground, because we're going to check at its feet there. The next thing I'm going to do is I want to just get some input. So I'm going to create a variable named h, just a shorthand for horizontal inputs, and I'm going to say input.getAxis Oops, see if I can type. Now you'll notice I'm not doing get button because a button is either on or off. I'm either pushing it or I'm not. Instead, I'm using another one of these built-in virtual axes, right? But I'm using the get axis, which is going to return a number between -1 and 1. So I'm going to be checking my horizontal input axis. Now, the horizontal input axis defaults the left and right arrow keys and the A and D keys on the keyboard. All right. So if I'm pressing left, which is the negative horizontal input axis, I'm going to get a -1. If I'm pressing right, I'm going to get a 1. If I'm pressing neither, I'm going to get a 0. All right. So it's just basically a three-way switch. And I'm going to do float V for vertical, and I'm going to do the same thing. Input dot get axis, and then vertical. There we go. Just like that. So that's the inputs. So we'll be able to control our player. And now I'm just going to go ahead and, for ease, I'm going to store those inside this vector3 I created. Now the vector3, right, is going to have 3 floats inside it, X, Y, and Z. And so I'm just going to sort of store that value in here. So I'm going to do a player input dot set, and I'm going to pass in H, which is my horizontal value. So H is going to map to left and right. 0 for my Y value because my character isn't really going up and down with these input keys. And then I'm going to do V for my Z axis, my forward and back. So that if I press left and right arrows, my Viking will move left and right. If I press up and down, my character will move forward and back. All right, so I'm just storing that in there. And I'm going to say, okay, well, if my player input equals, oops, there we go, equals vector3.0, which is just a default vector3 with nothing in it, all zeros, meaning the player is not pressing any of these keys. So if I'm not touching my keyboard, right, then my player input will equal 0, 0, 0. So if that's the case, then you know what, I'm just going to get out of here because I don't need to do anything else if the player's not pressing any keys, right? And my job is pretty much done. Now, if they are pressing some keys, I need to calculate where I need to be. And so I'm going to type vector3, and then I'm going to create a new vector3 which I'll call new position. And this new position, so this is where I want to be, is going to be equal to my player input, right? So this vector with my horizontal and vertical values in here. And then I'm going to multiply that by my movement speed. All right, there we go. And then I could leave this as is, but what would effectively happen is my my inputs would be my Viking would move much too fast. And in fixed update, this isn't so much of a problem. But if this was in regular update, if your computer was slow and my computer is fast, my Viking would be faster than your computer, and we get different play experiences, and because we're simply just performing this multiplication. So if we want to make it frame independent, speed independent, so slow computers and fast computers move at the same rate when playing this game, we're also going to want to multiply this whole thing by time.delta time, which is how much time has it been since the last time I did this calculation, or been inside fixed update, or been inside regular update. That way, if I have a really fast computer, time.delta time is really low, really small, and so I'm going to get a really small result of this multiplication. If you have a slow computer, time.delta time is going to be bigger, and so you're going to get a bigger number here. So everyone's computer is going to run at the same rate. So just time.delta time. It's just one of those things you just add on there. It's good. And so that's going to give me the offset where I want to end up. And so now I could do transform.translate. All right, translate is just a fancy way of, well, if I spell it right, fancy way of saying move. So I could move my Viking. However, I'm working with physics here, and transform.translate is basically just going to teleport me to a new spot. I don't want to do that. So instead, I'm going to move with my rigid body. So I'm going to say, well, I need to use my local rigid body. Rigid body dot move position, which is going to function very much like translate. It is sort of going to pop me into this new spot, but it's going to move me with velocity behind the scenes. And if I were to try to teleport into a solid object, it would detect that and instead just put me up against the object, right? It won't let me do that because it's going to be moving with physics. And so where do I want to go? Well, I want to go to my new position plus my current position. So transform.position. There we go. So that's where I want to be. And I also want to look the way I'm facing. So I'm going to say really easily here, rigid body.move rotation. All right. And or I'm actually not move rotation, sorry. I'm just gonna actually set the rotation of my rigid body. And I'm gonna set that, now this is gonna seem confusing, all right? I'm gonna set that to something called quaternion. Quaternion is one of those super sci-fi words that everyone sort of freaks out when they first hear. Quaternion is just a different way of looking at rotation. There's the traditional Euler way of doing rotation, 360 degrees about the X, Y, and Z axis. That's what everyone knows. However, to be more mathematically accurate, Unity stores rotations behind the scenes in something called quaternions. Now, I like to say that, there's really, no one in the world who understands quaternions. I like to joke around because they can be a little confusing. The rotation about the X, Y, Z, and W and whatever. What's really neat is that I don't have to actually know anything about quaternions. I personally know almost nothing about quaternions, and it's never ever been a problem because I'm actually just going to say quaternion dot look rotation, and I'm going to use this static class to do all the calculations for me. So all I really need to do is just say, hey, look, I want to look in this direction. I want to look in the direction of the keys I'm pressing. I don't need to know how quaternion calculates that or any of that stuff. It's going to do it and just store it as my rotation, and I never have to worry about it. So this is my class here. All right, so a lot of type in, but it's really not too bad. And so I'm going to pop back over to Unity now. Here we are, and it's going to take a second to compile. And so now my script should work. Now, before I actually hit play and test it out, the one thing I did is I set this, what is ground layer mask. It's looking for layers, right? And you can see I've got quite a few built-in layers here, and one not built-in that I've added myself. And you might be wondering, well, what does that mean? Well, if I click this ground, this is something I set up already when I built this. So here's this piece of ground I added when I built this level. And if I look in the inspector, I can see that for layer, I gave it this layer called ground. I specified that this is on the ground layer. All right. The nice thing is then if I go to my Viking, what am I looking for when I check to see if I'm on the ground? I'm looking for the layer ground. And I've already set up all of these things to be on the layer ground. And so now if I press play, I'll move around and I'll jump, and that's all well and good. Now, I am just sort of standing here sliding around, so that's kind of lame. We definitely want to animate that. I'm also able to just jump off the side, which is also a problem. And so I'm gonna kind of fix a couple of these things. Now we saw before how we created game objects. We can just drag stuff into the scene. We can add components to them and stuff like that. Well, if I want, I can create something called a prefab. Now, basically the reason we need prefabs is this. I've got this Viking. Let's say I create a second scene that also needs a Viking. Do I need to recreate this Viking? Do I need to drag in the model again, add all this stuff? I don't really want to do that. Not to mention that if I have other games that I want to use this Viking in and whatever, it just becomes a pain. And if I ever need to change, I need to find all the Vikings and make changes to them and whatever, which I don't really want to do. So I'm going to turn this into something called a prefab, which is short for prefabricated object. And I have a prefabs folder here with some stuff already in it. And again, the name of the folder is irrelevant. I'm just doing that to keep it organized. And if I want to turn this Viking into a prefab, all I got to do is just, again, click and drag. All right, drag and drop ability, just drop it right down here. And now my Viking, with all of the stuff that I've added to it, has been saved as a prefab, which is really cool because now I can just drag in a whole bunch of Vikings and, we can, just roll deep with our posse, right? And just do this whole thing. Some can jump and whatever. That can be a game in and of itself. But so there we go. I mean, so now I've got this prefab that I've created of this Viking, and then if I have a second scene, I just drag that prefab in. And since it's an asset on my hard drive, I can drop it in a different program or a different project. I mean, and I'll have a Viking there, and it's easy. So with that known, I have this prefab called World Colliders. I'll just drop it in here. Now we didn't see anything happen because I also have a layers drop down right up here at the top of the inspector where I can choose which layers I want to be able to see and not see. And I have Wall Collider as a layer that I've already created that this Wall Collider's game object is on, and I have that hidden. If I show it, this is what we see because they're these giant white squares that are the colliders for my level. And I have them as visible squares because it makes it easy to fix any problems that I find. But I don't want to see these while I'm playing or while I'm working, so I'm just going to go to my layer and I'm going to hide them. All right, again, the layers allow me to do that. I look at my game view though, I can still see them. I'm just hiding them in my editor, but the camera can see them. So I can click on my camera and say, you know what, you have a culling mask. What can you see? Well, you can't see wall colliders either. And so now they're here and they're invisible, but they prevent my player from jumping off the side because they're colliders, real physical collision. So I can't go anywhere. All right, makes it nice and easy to prevent that. Now, I also want to deal with the fact that my Viking is sort of just sliding around. So to do that, I'm going to go back to my models folder, my mini Viking folder, my Viking sword folder. And when I click on the Viking sword FBX, the actual model, not the prefab, not a game object, but the model, the FBX file, the asset, in my inspector, I'm going to see the import settings. All right, so I can see its model import settings, which I'm going to leave these alone. Any kind of rigs, which we can do like humanoid rigs or generic rigs or anything like that. Humanoid is really awesome for retargeting animations and stuff. And then the animations tab, and we'll see that this FBX has baked into it many animations. So I could say, show me the chop animation. There we go. That's the chop animation. Uppercut. There we go. Let's see. Spawn from above. Oh, that's pretty cool. All right. So all these animations are baked into this file. And if I want to access them, I just need to click this little arrow here, just to the right, that'll expand it and show me everything that's inside. And you can see all those little animation clips right here. There's chop and run and whatever. And so I want to add this to my Viking. So I'm going to click and drag idle, the animation, and just drop it on my Viking. Drag and drop ability. That's it. And the Unity is going to do a bunch of stuff, and that's going to result in me getting a new file here called Viking Sword, the same name as the game object I dragged that onto. And so now if I hit play, my Viking is animating, right? That's simple. It was pretty easy to do. All right. What magic sort of happened is contained in this file. So this is an animator controller, an animator controller, part of our Mechanim animation system. Before I show you what's going on in there, I'm going to add a couple more things to it. So I'm going to locate run. There you are. And I'm going to drag that onto the Viking. I'm also going to locate jump and drag that onto the Viking. Those are the three animations out of here that I want to use. And so now what I'm going to do is I'm going to double click right here. This is my animator controller, my animator window. All right, so I've got these animations, which we just saw. So there's my idle, there's my run, there's my jump. And if I press play and I select my Viking, I can go back to the animator window and actually watch the animation play. And if I wanted to say be in the run state, I could right click that and say default state. And now my Viking will just be running. All right. But since this is a finite state machine, I can only be in one state at a time, and I need to specify logically how we move around. So I want idle to be my default animation, but I need to define, how do we move around? Well, how do we transition from one state to the next? Well, I know that I can go from idle to run, so I'm just going to right click on idle and say make transition, and I get this little white line here. I'll click on run, and they'll become linked. I know I can go from run back to idle. All right, just like that. I know I can go from idle to jump. I know I can go from run to jump. And I know I can go from jump back to idle and jump back to run. So there we go. Now they're linked with these transitions. If I hit play, my Viking's going to sort of do this, which is a little odd. If I wonder what's going on, I can go back to my animator window and I can see exactly what it's doing. It's doing exactly what I told it to do. It's transitioning. All right, we told it how to transition. Now we need to tell it when transition. All right, I see that we have a question. Could you please show how you reached that screen again? This animator screen, I'm assuming is what you're talking about. Sorry, I saw your thunder. I just saw the question and felt like answering it. So there's a couple ways we can get here. So we can go to window and then animator, which right here to open that window, or I can go to an animator controller, which is a .controller file, and I can just double click it. Either way works, and then I'm in here. If that's not the window you were talking about, please just let me know. All right, so I've defined how to transition, but not when to transition. So in my animator window, I'm going to see here that I've got this layers. I'm also going to go to parameters. Parameters are basically going to be variables that I can expose to code to help control this animation system. And so I'm going to click this plus icon, and I'm going to add a new parameter of type float, which I'm going to call speed. There we go. And I'm also going to add another one of type bool called grounded. Now the names I give to this are important. We're going to use these soon. And then I'm going to go ahead real quick here. We can talk about, we got floats, which are floating point numbers, integers, booleans, which are true or false, and triggers, which are booleans that when you set to true, they set themselves back to false for like triggering one-off effects, like punching or shooting or whatever. All right. And so now what I'm going to do is I'm going to start setting these up. So I'm going to go from idle to run, not with exit time, which is what we were seeing before. Exit time just says, hey, when the animation is finished, transition over. So I don't want exit time. Instead, I'm going to transition when the speed is greater than 0.01. From run back to idle, I want speed is less than 0.01. For jumping, I'm going to go from idle to jump, all right, when grounded is false, when I'm no longer on the ground. I'm going to go from run to jump, again, when grounded is false. So if grounded becomes false, regardless of whether I'm in idle or run, I'm immediately going to transition to the jump state. Now, the tricky one is coming back from the jump state. So with jump back to idle, well, obviously I want this to be when grounded is true again, but how do I know which of these two states to go to when I'm back on the ground? I'm going to add a second condition. So if grounded is true and speed is less than 0.01, I'm going to idle. Now, if grounded is true and my speed is greater than 0.01, I'm going to go to run. And there we go. So that is my animation tree. Now, he's just sort of doing this here because I have obviously checked something wrong here, where we're going to say idle to run is grounded is false, run grounded is false, grounded is true, grounded is true. I might just be typing something in. Oh, obviously that's the problem because we just never said grounded is true because I've not actually hooked this into my code yet. So if I do this, the Viking will just be on the ground. However, still not animating. We haven't actually used these parameters yet. All right, so we're going to do that now. So another question, can we run this Unity game on Xamarin Forms, Android, iOS? So I don't know about Xamarin Forms. I'm not super familiar with that, but this will run on Android and iOS, absolutely. And I'll show you an easy way to build that here in just a minute. And so one last, I'm going to go back to my code here real quick. We'll hook in these animations. All right, so I'm going to come back here and I'm going to create, just like I have rigid body, I'm going to create a variable called animator, which I'll call anim.
Hey, Mike, while you're there,
sure.
We also had another question. For those public fields, can you make those public properties or do they have to be fields?
So you can make them public properties. However, Unity isn't going to know how to serialize that into the editor. So while you're more than welcome to have public properties, they won't appear in the inspector unless, so what I'm talking about is it won't appear here unless you write a simple editor script that just kind of tells Unity how you want it to display that information, right? So anything that's not a primitive or built-in type needs to have basically a custom inspector is what we call it that says, I want you to show it this way, which is useful because then we can add buttons, we can make lists appear, we can do custom classes, we can do all sorts of cool stuff. But properties are one of those things that Unity doesn't know how to render it here.
So you're better off just using a field in that case.
I mean, if you need a property, use a property,
yeah.
Right? And then you can just have a custom inspector for that. You know what? Just to make sure I'm not mistaken, let me just create one real quick. Now you see, this is where I'm going to mess up because I'm just trying to remember off the top of my head how to write a C# property.
No parentheses.
Usually I cheat. No parentheses. Thank you. Yeah, like I said, normally I just cheat, and this can't be a void, obviously. So public float my property. So we generally change stuff around. So I was saying that as the last time I checked. I wasn't sure if it's still true, but nope, that appears to still be true. So yeah, but you can write a quick and easy custom inspector to make that appear. It really is just a few lines of code. But Yeah, so again, use properties if you need properties, but if you need them to be serializable, that's going to require either a custom inspector or some other means of displaying that. All right, so in start, I just created this animator variable named anim, and so I'm going to say anim equals get component. So I'm going to get reference to that animator. There we go. And now using it is quite simple. So I remember the names of these parameters. So here where I'm jumping, I'm going to go ahead and say that I want to go, or actually, you know what? I don't even have to do that there. I can just come down here and just say anim dot set bool grounded, and I will pass in the value of whether or not I'm on the ground, right? That's fairly easy. So I'm not even going to do that here where I do the jumping. I'm just going to do that right here, grounded. And then every fixed update, it's going to check if I'm on the ground, and it's just going to pass that into my animator. Now down here, where I am getting my inputs for my vertical or my horizontal plane movement, I'm just going to say anim dot set float. So this one's at float, and the name of that float was speed. And I need to pass in just a float value. An easy way to do that is just going to do player input dot square magnitude, which basically just gives me whether or not I'm pressing these keys in numerical value. It'll be 0 if I'm not pressing any of these. It'll be some square magnitude of the vector, some value higher than 0 if I am pressing any of the keys. So we've got that there. All right, and that's it. Now through manipulating these two parameters, all right, my Viking will animate. So I'll come back here and I'll hit play. So I'm idling, then I'm running, I hit space, and I'm jumping. And there we go. Very easy. All right, so, and we can keep doing this. You will notice my Viking be a little drunk, right? Because you remember he's a capsule collider, right? Capsules are like eggs. They just want to fall over. A way we can fix that is in our rigid body, we can tell it that, hey, we just, we don't want to allow the inertia and stuff to knock our character around. We'll do all that through code. So now our character won't fall down, right? It's just gonna, it's gonna freeze that all that rotation from the built-in physics calculations. All right, and I'll save my scene here. So we can iterate on this and keep building, but I want to show you some other stuff within the engine that's going to allow you to kind of go further with it. All right, so scripting is fairly simple. It's C# and just knowing the API and stuff like that. And inside the editor, it's a lot of drag and dropping and components. It's fairly easy. It's a great iterative prototyping, fast to get started, process. And so as I'm going forward, I sort of want to improve things a bit in my workflow using a lot of our services. And so I'm going to come up here. I have this cloud button right here, or I can go to Windows Services. Either way, that's going to open this Services tab. And what I want to do is I'm just going to go ahead and create a Services Project ID. Now I have an organization here. I have several organizations. When I do these demos, I generally create them inside my delete this organization because that's just where I throw a lot of my throwaway projects. And I'm just going to go ahead and hit create. That's going to create a project ID for me. And then I come in here and I can see that we have a bunch of these services. So this is going to turn on ads. Now, don't worry, it's not like we turn on ads and we start showing ads and stealing money or whatever. This just enables the ads API. So now you're able to show ads and begin monetizing in a very, very easy way. If I want to have, say, analytics, so I know when people are playing my game, I can just click on my analytics here and just turn it on. And I can say, okay, is this app primarily targeted to children under the age of 13? It is not, so I'll just hit continue, and that updates my COPPA compliance there. And to complete my integration, I'm just gonna hit play. And in a second here, I should see that appear. Any minute now. It all really depends on your internet speed or whatever. Maybe I'll come back to it. Yeah, press play. Anyway, maybe I have to leave play. Anyway, I'll come back to that in a second. Sometimes it can take a minute. Oh, there we go. I saw it for a moment. Sometimes it can take a minute. I'm just going to give it a second to update there. And if I want to use source control, now obviously Unity works with Git, Mercurial, SVN, Perforce, whatever you want to do. But if you're just looking to get up and running and collaborating with your team quickly, easily, you don't really worry about that stuff, you can turn on Collaborate, which is going to basically host your repo on Unity servers securely, and just have built-in, organizational stuff. So only people in your org and people with the right permissions and stuff can access it. And it's basically going to be a form of source control. So I'm just going to turn on Collaborate here, and it's going to go ahead and start getting my project ready for collaboration. Where I see this collab spinning, it's figuring out everything that's in my project, and it's looking for changes and all that stuff. And it's going to say, okay, you basically have the entire project you need to synchronize. Now, I'm not going to push this up right now because that's going to just take too long. But I'll give you a demo of that here in a second. But you can see now Collab is on. Let's see, did analytics update yet? They've changed the dashboard, so maybe you have to see it through the dashboard. At any rate, normally it'll just show you the events and stuff right here just to verify that it's working, but there it is. Okay, so just second time was a charm. All right, so we can set up custom events and everything, but even if we don't do anything else, we just turn on analytics, we're already gaining a whole bunch of data about our games. Who's playing it? We're not who's playing, it's not like we're spying on anybody, but you get application activations and regions and stuff like that, all the stuff that's completely legal to look at as far as game analytics stuff. So don't worry, we're not like stealing private info or whatever. And you can access that all through here. You can go to the dashboard, you can set up funnels and do all sorts of cool analytics stuff. And it required no code, right? You just turn it on. And then I've got Collaborate here. I can also set up Cloud Build, which I'm actually going to show you in a separate project. So that we're not sitting here watching like an update from Collaborate, I actually have another version of this project. And this version here, I realize now I still have the darker skin, so I'll switch this up so we might be easier to see for some people. We'll have the lighter skin here. And I've added a different skybox to it and added some image effects. And if there's time, I can talk about how that worked. But you can see here that I've already synced my Collab project and I have some history, right? So we can see here, and if I want, I can see what assets were changed. I can go back to it. I can see that these were all from me. And what's neat about this is since it's first party integrated into the engine, I can see that if I want to work on this scene, the scene that I'm in right now, I get this icon here that I'm thinking, wait a minute, someone else, so Amphoteric is just me, it's my other account, it's my personal one, someone else is editing this right now. And so if I work on this file or this scene, I might have a conflict. And now I have this open on a different computer here, and I'll just add a little note here and publish that, and that'll take just a quick second. And now here I can see already, oh, wait a minute, they have an update. That was my other account, changed to scene. All right, and if I want to learn more about that, I can click on it, learn more. I can just update. It's going to pull that down here. It's going to say, hey, this scene changed. Do you want to reload it? I forget what it is that I changed. Changed something. I think I moved the camera a little bit or something. And so now this isn't here. And I can see on my other computer, there's an icon saying that I'm working on this scene, and any of my assets that I want to change or manipulate or whatever, I can do that. And so, obviously that makes collaboration really simple. And I can have my orgs all working on this stuff. I can see the stuff everyone's working on, and I can see, hey, what stuff do I have in progress? What conflicts am I experiencing? People working on the same files and stuff like that, and that makes that process really simple. Finally, building, right? So let's say I want to build this. So I can go up to File and Build Settings, and in my Build Settings, I can choose any of these platforms. I can do Android. I don't know which modules I have installed. So Android, WebGL, iOS, tvOS, Tizen, Xbox One, PlayStation, Vita, PlayStation 4, Windows Universal, Facebook, Samsung. All of the ones you don't see here, but were in the list originally, might just require, so the Nintendo ones, you need an account from Nintendo to do that. And that opens up the module here. And then if we want to do VR, I can just leave this as PC, Mac, and Linux and just say, just VR. Now it's an Oculus game, or now it's a Vive game. So that's all pretty simple. So I can do a PC, Mac, and Linux build here. I can do an Android build. Now I'm on a PC, though I can't do an iOS build. And every time I do a build, I have to sit here and wait for it to do the build, and that takes up time where I'm not working on other stuff, and that kind of stinks. So what I can do is I can use a different one of our services here. I'm going to use Cloud Build. Now, Cloud Build works really easily if you have Collaborate, because we already have a copy of your repo because it's a source control, and so we can just build it for you. Now, you can use Cloud Build even if you're not using Collaborate. You just need to give us access to your repo. And what Cloud Build does, I'll just click on here, Cloud Build enables us to do constant builds, like your own personal build farm, sending you builds of all the different platforms. So I'm just going to click Start Using, and I could do, you know what, build me a 64-bit Windows, but I'm also going to do Android to start. So I'm going to say build for Android, give it a label, default Android's fine. There's no subfolder there. I want you to build it on the latest version. I'm going to create some credentials here. I need a bundle identifier, so I'll just do com.mike.viking. Helps if I spell it right. There we go. And I'll just do a debug key store there. And now that's it. It's actually going to kick off a build. And we'll see it here in just a second as it's kicking off a build. And I will get an email as soon as the build is done. And I can open the email on device and immediately install it on the device. And what's awesome about this is I can, if I'm working with a team and I'm not necessarily needing to download their entire project, my role is just to try out the builds. Maybe I'm in QA or anything like that. I can just have the build sent directly to me. And so that's my Android build. I can just come down here. I can add a new target, and I could say Windows 64. I can do all that, and I don't think I need to do anything special there. And that'll add that. And I can say, hey, do you want to, do it continuously or only when I kick it off or whatever? And so there you go. It's like having your own build farm, which is really cool. Now, the services that I showed you that we're using here, they're all available for personal users. Collab or Unity Teams and stuff like that is in beta. It'll be finally or fully out here very shortly. And so, but still, personal users can use all of these features, Cloud Build and all that stuff. I believe for my services, I actually have the personal version of all of these services. Now, besides that, though, we do have Unity Plus and Unity Pro, where you just get maybe faster build farms or whatever. But this is all usable for personal. Actually, I just looked here to see two questions that were being asked. What features are available in personal, and is Cloud Build included in the free version? And the answer to both, the answer to one is yes, it is available in the free version. What features are available in personal? So everything that I've shown you, everything that we've seen, all of this is available in personal. There's no in-engine differences between personal and pro, besides the skin and the splash screen control and stuff like that. With Pro, you get access to better tiers of the services. So Collaborate can have larger projects, more people collaborating. Cloud Build has faster build farms, stuff like that. I don't believe there's any difference on ads. Analytics has different new types of custom events and things like that. So, but all of these are available to personal users, right? And so it works for everybody. Again, democratizing game development, right? We want everyone to have access to this stuff, and that's very important for us. So. Anyway, that's what I wanted to show sort of in engine, because we are kind of out of time. For anyone interested in where you might go to learn more, we have a few places that I can recommend. So first off, we have the Learn section of the Unity website, unity3d.com/learn, where you can find all sorts of tutorials, documentation. We do live training. So if I click on this, you'll see, well, actually, we're taking a summer break right now, but you can see a countdown. In 20 days, we'll be back with our next session. And you can see here that we've got obviously the archives of all the previous past sessions, or I used to do a lot of these, so my name is on some of these. Yeah. But we have a couple other guys that do a really awesome job with these as well, so definitely check those out. And so usually they're every other week, but this is the summer break there. And you can also see that we've got video projects here, full-on tutorials, full projects, start to finish games, as well as different topics to learn, many articles and videos to guide you through that. We have our documentations, we have our manual, which is going to be more article based, how to work with and use all of these things. We have our scripting API manual, again, all accessible through Learn on the documentation section here. And then if you're a Visual Studio user, right, especially if you're Visual Studio for Mac, so I was using Visual Studio obviously for PC, but they do have a documentation site for Visual Studio, specifically how it interacts with Unity, which is really awesome here. So using Unity tools and getting started and whatnot. That's going to have download links and all that stuff, walk you through how to do debugging and everything, which I suppose I actually didn't show you, which one of the cooler things you can do here is if I'm trying to debug with Visual Studio in my Viking game here. I'll just pop this up real quick. I know we're out of time, but I can do this. I can just attach this to Unity by just clicking that little button there. And then let's say I want to debug what happens when I'm jumping. I can just add a breakpoint. And then in Unity, I can just come back here. I'll hit play. And when I trigger that breakpoint or when I jump, it's going to come back here and I'm going to get full debug, all that super cool stuff, right? So you get full debugging, your immediate windows, call stacks, all that stuff within Unity, which is really cool, or within Visual Studio, which is really cool. All right, so a little bit over on time there, but I think I got through everything I wanted to get through. I know it's a super rapid session with only being an hour. I don't know if anyone has any questions. I'm happy to answer those.
Yeah, so I did have one that came through email. Is if we're targeting, let's say, Android or iOS or whatever, and is there a way to make it adjust to the size of the screen? So maybe like a phone, the game's going to be a little different than an iPad, for example.
Yes, absolutely. So we're talking about basically screen resolution independence, or or however we want to phrase that. So here I've sort of been hitting play, and we've just been seeing this work. But the way the camera works, the camera is based on this concept of a frustum, right? A camera frustum, which basically means it's going to see not in resolution, but in aspect ratio, right? And the camera frustum right now is kind of is this sort of fixed size. We really know what it is. If I go to my game view, right, I can see that my game view is set to free aspect, which means however much size this window has, right, that's what my camera sort of sees. You can see if I get like this, it gets sort of fish eye, lensy, and whatever. But if I want to test against a specific device, let's say I want to do iPad, which I believe is still 4:3, I can click on this. And so this is what my game will look like on an iPad or any device with 4:3 aspect ratio. This is what it'll look like. Now, obviously, higher resolution, will have more pixels per inch of the screen or whatever, but this is what I'm seeing. I'm dealing with aspect ratios. If I want to see what it's going to look like on a 16:9 aspect ratio, I can do that. Now, if I want to see what this is going to look like on, say, an actual physical device, I have a target resolution, I can just come over here. So I can come down here to this plus icon. I can create new aspect ratios. I can create actual resolution. So let's say I want to see what this looks like on a 1080p screen. So I click on that, and this is what this looks like on a 1080p screen. Now, this is simulating 1080p because I am on a 1080p monitor. So if I had a 4K monitor, this would show me actually what it's going to look like. But you see how that doesn't look any different from 16:9 because it is effectively 16:9 aspect ratio. So we're not really dealing with pixel dimensions, right? We're dealing with these aspect ratios. If I'm dealing with UI, I can set my UI to scale. I can set my UI to skew and whatever. And that's a bit more of a, I don't want to say a complicated topic. It's pretty simple, but basically you just say, hey, I want this to scale with my screen or whatever as far as UI goes. But as far as the game stuff, anything's 3D or 2D in my game, the camera's going to handle that automatically, which is really cool, just based on these different aspect ratios. Any other questions?
No, it looks like that's it. So like you said, there's, we only had an hour, so there is a lot more to discover with yes. Unity. Definitely go Absolutely. Check out that Learn site on the Unity 3D site. That looks fantastic. Are those all free, the learning ones?
Absolutely. Yep. Cool. Everything there is free.
Well, that's great. So like I said, one of the things when I first saw this is it blows me away how easy it is to just kind of start dragging and dropping and putting together a game. I always thought there's no way I could ever create a game, just creativity-wise. But sure. With Unity, it looks like I actually could, which is fantastic.
Yeah, so. It's super, super simple. And if anyone has any questions or anything they think of later that they didn't ask, you can always reach out to me directly at Unity, Mike@unity3d.com, or just on Twitter at MikeGeig. I'm happy to answer any questions you'll have.
Fantastic. Thank you so much, Mike. Thank you for everyone attending and all the questions. We're going to have this video up for Xamarin University students in the next couple of days, and then it'll be public in 30 days or so. So again, thank you, everyone, and I hope this really kind of piques your interest in game development. Thanks again, Mike.
No problem. Cheers.